Hello, dear learners. Today we are going to solve a question which was asked in Germany's final exams. It is a calculus question in which derivative and integration is observed of the students. So, given is the function f such that x is mapped onto 8x cube plus 3x defined on R with derivative function f prime. In part A, you have to find out the f prime 1, means calculate f prime 1. Part B, determine an expression for the antiderivative f, capital F of small f, whose graph passes through the point -1, 5. Okay, so to find the value of derivative at x is equal to 1, we first need to find the general derivative function f prime of x. So here we will be using a power rule. Power rule of derivative is equal to or is defined as d by dx of a x to the power n is equal to a n x to the power n minus 1. So what happened here? You can see the power is dropped and is multiplied with the coefficient which is already given. So a is the coefficient of x here. So the power here you can see is multiplied with coefficient, and there will be reduction in the power by 1. You can see that 1 is subtracted from the power of x. So it is the power rule that we have to drop the power and we have to subtract 1 from the power. It is known as the power rule. Now uh, we will differentiate our given function, which is f of x is equal to 8 to 8x to the power 3 plus 3x. Now we will write here f prime x is equal to, now here you can write it as, because we are going to differentiate all the terms included in our function, you can see there are two terms here, so we have to, and both terms are adding, so we will be differentiating each term one by one. So here we can write d by dx of 8x cube plus d by dx of 3x. As you can see in the power rule, we have to drop the power down with coefficient. So here 8 is already there. The power of x here is, you can see 3. So we will drop it down and we will multiply with the number which was already present before the variable x. And now we will reduce the power of x by 1. So it will become 3 minus 1 plus, now 3 is already existing there. Here you can see it is 3x. It means that the x power is not visible here, so we can, whenever x alone is there, it means that 1 is present in the power and 1 is present in the coefficient. So what is going to happen here? Now 3 is already present there, present there, and we will drop the power of x, which is 1. It will come here, and the power of x is already 1, so we will subtract 1 from it by using the power rule. Now it will become our f prime x finally gives us 24 x to the power 2 plus 3 x to the power 0, which is equal to x to the power 0. And as you know, because x to the power 0 is equal to 1, therefore uh, this x to the power 0 is 1, so we can simply write 3 here. Now we have got f prime x, we have differentiated our function. Now let's move to the next part of the question. Now we have to find out, actually what we are going to find here, we are searching for the answer of f prime of 1. For f prime of 1, we should have f prime of x. So it is already, it is there. Now we can substitute x as 1 here. So f prime 1 is equal to, as you can see, x is replaced with 1 on the left hand side. Therefore, we will replace x with 1 on the right hand side. So it will become 24. So in place of x, we are going to substitute or insert 1 plus 3. Now 1 square is 1, so it will give us 24 plus 3 is equal to 27. Therefore, f prime 1 is equal to 27. So it is our part A, and here you can see in part A we have to find f prime 1, so we have got the value of f prime 1. So second part of the question is determine an expression for the antiderivative f of f whose f of f whose graph passes through the point 1, -1 and 5. So here we can find an antiderivative f of x is found by integrating f of x, means we have to integrate f of x, it will be antiderivative. Actually, the integration is the reverse of differentiation. So one thing is very noticeable over here. When we will be integrating, so the general rule of integration is going to write over here. So integration of any function x to the power n dx is equal to x to the power n plus 1 divided by n plus 1 and plus constant of integration. So whenever we will be differentiating any function, suppose we have a function dy dx of x plus 1 or x square plus 1. So the x square's derivative will be 2x, and the constant or number's derivative is always 0. It means when we will be differentiating any function, we will place 0 in place of the constant, because constant differentiation of constant is 0. So as you know, the integration is the reverse of derivative or differentiation. Therefore, that constant which became 0, or we used to become 0 in differentiation, in integration it is reversed. So here you can see a constant of integration is there. Whenever we will be integrating any function, we will place a constant of integration over there. Now here in this function which is with us, you can see the function is f of x is equal to 8x cubed plus 3x. So we can write it as f of capital F we will be using for the integration. F of x is equal to integration of 8x cubed plus 3x dx. Now it will become f of, as the rule is written above, it will remain as it is because it is the coefficient of x cube. So the x cube's power will become 3 plus 1. So integration we have to increase the power by 1 by adding it in 1, and then the same thing is divided, plus 3 x to the power 1 is already there, so we will add one more and it will become 1 plus 1. Now here it is c, which is the constant of integration. Now it will become 8 x to the power 4 over 4 plus 3 x to the power 2 over 2 plus constant of integration. We can write it like this. So here you can see this 4 will cancel out, and here we will get f of x is equal to 2x to the power 4 plus 3 over 2x to the power 2 plus constant of integration. Now here the demand of the question is determine an expression for the antiderivative. You can see the statement is telling us antiderivative of f for f whose graph passes through the point -1 and 5. Now here you can see the point which is given is -1 and 5. The given point is -1 and 5. It means x on this point is -1 and y is 5. It means that f of -1 is equal to 5 because the point, the problem states that the graph passes through the -1 and 5. Therefore, f of -1 is equal to 5. Hence, we can write 5 in place of f of x. Means then we will substitute 1 -1 here, we will get 5. Therefore, we are doing this process for the value of c. So here we can write in place of f of x, we can write 5 is equal to 2, and in place of uh, x, because for f of -1 x, f of x is 5, therefore we are going to write 5 is equal to -1 to the power 4 plus 3 over 2 -1 to the power 2 plus c. Now it is going to give us 5 is equal to, so minus 1's power is 4, so it will become plus 1. So here we will be getting 2 plus minus 1 square on here will become 1. So we will get 3 over 2 plus c. Now it is equal to 5 and here it is 2 over 1. So if I want to make it make the denominator same in these both fractions, so I will multiply the first fraction. This fraction will multiply with 2 on both numerator and denominator. So it will become 4 over 2 plus 3 over 2 plus c. Now it is going to become 5 is equal to 7 over 2 plus c. Now c is equal to 5 minus 7 over 2. Now here we can write it as, again the same thing is there, we have to multiply because it is 5 over 1, so it will become 2 and 10. Denominator is same in both fractions. Therefore, c is equal to 3 over 2. Hence, our final expression will be f of x is equal to 2x to the power 4 plus 3 over 2x to the power 2 plus 3 over 2. So the value of c which we have derived here, we have substituted the value here in this function. So we have got the final answer. So this is the final answer. Hopefully, so this question is asked in Germany's final exams, school exams. So hopefully you have got the idea. Thank you for listening and watching.